Hi everybody, and welcome to this intermediate course on Python. My name is Max, and in this video we're going to cover all the necessary topics that you need in order to level up your Python skills. In this list you can see an overview of all the topics that we're going to cover, and I'm going to be leaving the timestamps in the description below, so feel free to skip to the parts that are most relevant for you. If you're interested in learning how to program Python or other programming languages, then this channel that you're on right now is a good place to start. So consider subscribing, and that being said, let's get right into the first topic. Let us briefly cover the differences between positional and keyword arguments in Python. I want to preface this explanation by first talking about the differences between parameters and arguments, because many people use these two words interchangeably, but they're not the same. Moving on, we're going to talk about positional arguments, then move on to keyword arguments, and at the end we want to look at what order the parameters need to be in so that we don't get any mistakes. So what exactly is the difference between a parameter and an argument? When we talk about parameters, then we talk about what we have in the function definition. So over here you can see I'm defining a function, and the function is conveniently called function. And into this function, I'm passing in two parameters over here. So these two things over here, the a and the b, are the parameters. Now that is in contrast to the arguments, because the arguments are what I pass into the function call, the values that I'm assigning to the individual parameters. So that is the difference between these two things. So let's make sure we distinguish properly between the two in this video. Let us now cover positional arguments. When we talk about positional arguments, then we are talking about arguments which we're passing into a function call where the order of the arguments actually matters. So let's have a look at this very easy example. Over here I've defined the function positional greet, and it is a function that takes two parameter values, the first name and the last name. And all it does is it prints out hello, first name, then it adds a space, and then the last name. Now, in this very first function call over here, I've added Bill as the first name and Gates as the last name. And these two arguments are positional arguments because the position that we order these two arguments in matters in this case. So if I go ahead and execute this, you can see that it prints out hello Bill Gates. But if I now switch up the order of the input values, you will see that the order is also going to be reversed in the console output. So as you can see with positional arguments, the order with which we pass these values into the function call actually matters to us. In contrast to the positional arguments, we also have keyword arguments. And here the order that we use when passing the individual arguments into the function call does not matter anymore. So if we have a look at the example over here, we're defining the function keyword greet. And again, we have a first name, a last name, and this function does exactly the same thing as the function did earlier. It simply prints out hello, then the first name, adds a space, and then puts the last name. Now the function call is where it gets interesting, because over here we have the keyword first name, and we're passing in Bill for the first name, and then we have the last name, and we're assigning the word Gates to the last name. So if I go ahead and execute this over here, you can see that it says hello Bill Gates. Now we're going to do exactly the same thing that we did earlier, which is reverse the order of the arguments in the function call. So over here you can see first name Bill, but now it's in the second position, and the last name Gates is now in the first position of this second function call. But if I execute this again, you can see that the result remains the same. So even though I've turned around the arguments, the result remains the same, which is in contrast to what we had earlier. So just remember, with keyword arguments, the order does not matter. Last but not least, let's cover the order of the parameters and the arguments so that we don't get any errors in our code. Over here you can see I have created a very simple function. The function is called profession, and all it does is it takes the name, age, and job title and puts it in a sentence. So if I go ahead and execute this very first example, you can see it says Max is 27 years old and is a lawyer. All right, so now we have learned that when we have positional arguments, we can put them in any order we like. Of course, it doesn't always make sense. So over here, I've switched up the order in the second example, and you can see that now the sentence is a bit quirky, doesn't make any more sense, but of course the code is still executable. One issue that we run into is when we try to pass in positional arguments after keyword arguments. So over here you can see I have a keyword argument followed by 2 positional arguments. But if I try and execute this, I get an error, and it even says in the explanation down here that the positional argument follows keyword arguments. And that makes sense because these 2 are positional arguments and this over here is a keyword argument. And since the positional arguments follow the keyword arguments, we cannot execute this line. So how can we go about solving this? We need to make sure that we always pass in the positional arguments before the keyword arguments. So this very last example over here will work again. I can execute it without any problem. It says Max is 27 years old and is a lawyer. And now that simply works because, of course, I have made the right order over here. And of course, you can add multiple keyword arguments into your function call. So perhaps if I add the age here as another keyword argument, this will still work. So I'm executing it again and still get the right result. But let me show you one last example where it wouldn't work, and that is if you try to make the keyword argument in the middle of the 2 positional arguments. So this will not work anymore. Whenever we create a function which should be able to take a variable amount of arguments and keyword arguments, we use the args and kwargs in the function call. So that being said, we're going to look at positional and keyword arguments. And after that, we're going to look at the args and kwargs as functional parameters. In general, the difference between keyword and positional arguments should be pretty clear. Just to give you a brief example, over here I have the function greet, and it takes a first name and a last name and puts it into a sentence. And all the sentence says is hello, first name, space, last name. So with positional arguments, as we have them over here in the function calls, the position of the arguments within the function call matters. So over here, if I execute this highlighted line of code, you can see that it prints out hello Elon Musk. But now if I were to turn around these 2 arguments, these 2 positional arguments, then you will see that the first and last name are switched around. You can see down here, now it says hello Musk Elon. So bear in mind, with positional arguments, the position of the arguments within the function call matters. Now that is not the case for keyword arguments. Over here you can see I have the function call to the function greet, and now I have added 2 keywords over here. So the first name is Elon and the last name is Musk. So if I go ahead and execute this, you can see that the sentence is printed correctly. It says hello Elon Musk. But even if I were to switch the arguments around, so now the first name is in the second position and the last name is in the first position, that will not matter over here. So if I go ahead and execute this, the sentence at the bottom is still correct because these are keywords, and it's mapping the first name to the first name over here and printing it first, and then the last name to the last name and printing it last. So remember, for positional arguments, the position of the arguments in the call matters, and for keyword arguments, it does not. Let's turn our attention to args now. So we use it whenever we want to pass an unspecified number of positional arguments into a function. So if we have a look at this first easy example, I have defined a function. It's called argsExample1, and it takes as an input the args. And all this function does is it prints out the data type of the args. So since I am able to pass in any unspecified number of positional arguments into this function, I might as well choose to pass in none. You can see the brackets over here are empty. So if I go ahead and execute this, you can see down below, it gives me the data type of the args, which is a tuple. And that's interesting to know because whenever we pass in any values into the function call, they're being saved in this args variable, which is a tuple. To see the implications of this, let's look at the second example. So we've defined a function called argsExample2. And over here, I simply choose to print out all the individual values in the tuple. So I'm looking in this for loop, I'm looping through 0 to the length of the tuple, and I'm printing out each and every single value. So over here you can see I have the values A, B, C, and D in the function call. So if I go ahead and execute this, you can see each individual value being printed out. Let's have a look at another easy example to see the implications of args and how we can use it. Over here at the top, I have a function called addition1, and I'm adding the values A and B together. So all this function does is return the sum of both numbers. So if I go ahead and execute this very first example, you can see I'm adding 4 and 7 together, which gives me 11. If I were to choose to add even more numbers to this, so let's perhaps add 4, 7, 8, 9, and 10, then you will see that it already says that I'm inputting unexpected arguments. And if I go ahead and execute this, you will also see the error come up at the bottom, which says that addition1, so the function we just created, takes 2 positional arguments, but 5 were given in total. And that's true because over here in the function call, we have 2 arguments, but no, I mean over in the function definition, we have 2 positional arguments, but then below in the call, we have 5. So that does not work. So how could we create a function that allows us to add an arbitrary amount of numbers together without having to specify the exact amount? So that is where the function 2 over here comes into play. Over here, I'm allowing for an unspecified number of positional arguments by using this args input. Then I'm saying that the sum is initially equal to 0, but I'm going to loop through all the arguments saved in the tuple and add it to the sum and print out the sum. So if I now go ahead and perhaps copy the values here and paste them back down here, and then I try to execute this, you can see that it does in fact add together all the individual numbers that I've added to the function call. So even if I go ahead and add some more to this, it will always work. You can see that the output is still correct. Now that we've looked at args, let's move on to quargs. Quargs are quite similar because they allow us to pass in an unspecified number of keyword arguments into a function. So as before with args, we're going to take a look at the data type that we're dealing with first. So over here I've created a function similar to the one we've seen before, but instead of args, I'm using quargs. If I go ahead and then execute this, you can see that now instead of a tuple, we're dealing with a dictionary. So whenever we pass in any keyword arguments into the function call, we are saving them in a dictionary. To see this, we can look at the second function down here. We've defined the function quargsExample2, and we are simply printing out all the items of the dictionary. So if I go ahead and execute this, you will see that it says that the dictionary items are keyword 1, which is A, and keyword 2, which is B, which is exactly the two values, or specifically the two key value pairs that we have in the function call. And since I'm using quarks, which allows me to add an unspecified number of arguments into the function, I can even go ahead and add more than that. So let me show you by perhaps adding a few more. So we have keyword 3 and keyword 4, and we're going to make this C and D. And after executing this, we have a similar result, but we're also getting the new values. So we're still getting the dictionary, but now we also have the keyword 3 and the keyword 4. The map function is very helpful because it allows us to apply a function to multiple elements in an iterable. So if you have a list of numbers, you can apply one function to each number in the list. So we're going to take a look at what map exactly does. Then we're going to use it with lists, tuples, and sets. Next, we're going to look at built-in functions and that we can also use map with these built-in functions. After that, we're going to have a map function that takes multiple iterators. And finally, we're going to use the map function with lambda functions. So what exactly does the map function in Python actually do? Let me introduce the concept of the map function by using a simple example first. So over here we have a simple set of numbers 1 through to 6. And there's nothing special about these numbers. All we want to do is we want to square each of these individual numbers from the set. So we want to square them. And the way we do this is within a for loop. So we're taking an individual number in the numbers list. Then we have defined a variable x, which is simply the square of an individual number. And then we are appending this x to the results list, which we created up here earlier. And finally, we are printing out our result. So if I go ahead and execute this, then the result should not surprise you. You can see down below that I am getting all the numbers from the initial numbers list squared. So the 1 we had earlier becomes the 1 now, then the 2 became the 4, which I've just gone over with my pen with, the 3 becomes the 9, and so on and so on and so on. So you can see that worked like a charm. But there is another way to do this in a simpler way, and that is using the map functionality. So how can we do exactly the same thing that we just did using map? Because after all, map allows us to execute a function on an iterable, such as a list, and it then applies the function to each individual element of the iterable. So over here I've defined another function called square, and it returns the number that we input squared. And when we want to use map, the first argument needs to be the function that we want to apply to all the elements, and afterwards we want to input all the individual iterables. So in this case we only have one. We could have multiple, we'll see that later on, but here we're only using one. So here we have the numbers squared saved, and afterwards we're printing them in the data type list. So let's go ahead and execute this. And you can see further down below that I have the desired result again over here, which is all the individual numbers from the numbers array squared. And one thing that you should pay attention to is that I have over here specified the data type explicitly before printing it. If I had not done that, so if I had left that out and simply printed out the result of this over here that I've highlighted in blue, you will see that we simply get the map object returned. And so that is a bit unlegible. You don't really want that. So you always need to make sure that you turn the map object into some sort of data type that you can read. So that doesn't necessarily need to be the list. It can also be a tuple. So let me write tuple in here and execute it again. So if I have the tuple and execute it, you see I get it as a tuple. I can also have it as a set and execute it again. And now this is a set because we have these curly brackets. All right, so that's the concept of map. Let's move on. Now I want to show you that we can actually use map with different data types of the iterable. So as long as what we're inputting into the maps function is an iterable, it should work. I have 3 examples over here. So the first one over here is a simple list, as you can see from these square brackets. Then next up is a tuple down here, a tuple which has these rounded brackets. And finally, we have these curly brackets, which is a set. So we have these 3 different examples, and they all have the numbers 1 through to 6. I've also defined a function which simply doubles the number that we input. Over here you can see we're returning n times 2, so we're doubling the result. And then I have added the map function over here 3 times, and I have done so for each of the individual containers. So for the very first one over here, which is a list, I have used the list. Then for the tuple, I have used the tuple. And finally, for the set, I have used the set, as you can also see from the individual names that I have input over here. And so after that, we saw earlier that it is not enough to print the individual result outcome. So it's not enough to simply set a print statement around these things, because all we get is the object. So over here, we're going to see that we retrieve the objects. But after that, we'll be able to see that we can convert the map object back into a list, tuple, or a set. So let's go ahead and run this code. But before I run it in its entirety, let me just run it up to the objects. So over here, you can now see in the console output that I have retrieved 3 map objects, which corresponds to the 3 map objects we've created here. But let me get rid of those, and let me now get the individual lists, tuples, and sets. So let me go ahead and execute all of this. And now what you can see is that we have retrieved exactly the result that we wanted to, because of course you can see that we have doubled all the numbers in the iterable. So initially we had 1, 2, 3, 4, 5, and 6, and we had it for a list, tuple, and a set. And now we have 2, 4, 6, 8, 10, 12. So this function was applied correctly to our iterable. Now, one thing that I want to show you still, and that might be something which you have already asked yourself, is in my example, you can see that I have created a list, for example. I've created a list, then I have put it into the map function over here. And subsequently, I took that list and then converted it back into a list. But can I, for example, take the initial list and turn it into something else? Yes, sure you can. I mean, let me briefly show you that you can, for example, turn this into a tuple. So if I go ahead and execute all of this now, hold on, you can see that I now have a tuple because we have rounded brackets, but I can also turn it into a set. So as long as we have a map object, and you can see down here now that it's a set. So as long as we retrieve a map object, which is exactly what we're retrieving here for these individual containers, we can then convert it into anything else from that map object. Surely enough, you can also use the map function on built-in functions. So to just briefly demonstrate that, over here you can see that I have another numbers list, and I have a couple of negative numbers mixed in with some positive numbers that are over here. Let's say we want to retrieve some absolute values. So we want to turn the -2 into a 2, and we want to turn the -5 into a 5, and the rest remains the same. Then we can do that quite simply by adding the map function, then putting the function into the map as an argument. And this abs over here, which stands for absolute, is simply a built-in function. It's built into Python. And you can see that if I take it as an argument over here, as the first argument, and then also input the list of numbers over here, that I can go ahead and print the values out, and it will give us the value that we desire. So let me execute this, and you can see that we have actually applied the absolute function to the numbers list, because now we have all the absolute values in the list. And surely enough, this does not only work for the built-in function absolute. If we take another built-in function, such as the length function, which returns the length of a string, we can have a words list. So over here we have the sentence, "How are you doing today?" And let's say we want to retrieve the number of characters in each of these individual words. So we expect to get a 3 here, a 3 here, a 3 here, a 3, 5 here, and a 5 here, because that corresponds to the number of letters in each individual word. So then we can go ahead and execute this, and you'll see that this will also work just as fine. This is exactly the result we expected: 33355, 33355. So built-in functions are also compatible with the map function. Now it's going to get a bit more interesting, because we can actually use map with multiple iterators. So what does that mean? So if we have the map function, we have in the previous examples always had a function, and we have then had one iterator. So I'm going to write iterator 1. But that does not necessarily need to be the case. We can also have multiple iterators. So there can be a second, there can be a third, and so on and so forth. So to demonstrate this in an example, I have now got two lists. I have beginning and end. And if you look closely at these lists, you will see that if we concatenate them, so if we put them together, they give us some colors. So if we take BL and UE, we have blue. If we have GR and EEN, we have green, and RE and D is red. So now we have then got a function which concatenates the two strings. So we have one string argument, another string argument, and we are returning a string which is simply the addition of both the strings we input. And if we now use the map function to do this job for us, so the way we would do it is we would take map, we would then add the function that we want to apply to each element in each of these individual two lists that we have at the top. So I have input the first list and the last list with the beginning and ending of each word. And subsequently, we have then on this part over here got the map object. And then we are taking the map object and converting it into a list. And that is exactly what we're printing out. So if I go ahead and show you the result, so let's go ahead and execute all of this, you can see that down below in the console output, I am getting the concatenated list of colors as I wanted. So that goes to show that you can have multiple iterators with the map function. Moving on to the last thing that I want to show you concerning maps, I want to show you that you can also use lambda functions with maps. So if you don't know what a lambda function is, don't worry, I'm going to explain that briefly as well. So over here we have a very simple example of a squared function. It's actually the one that we saw at the beginning of this section. And we have over here the numbers list with numbers 1 through to 6. And we have the squared function, which simply returns the squared of the input parameter. And what we're doing here is we have the function square, and we are applying it to all the numbers in the numbers list. So clearly, if I go ahead and execute this, you will see that we get the numbers squared. That is no surprise. But how could we do this in an even simpler way using a lambda function? One way to do that would be to, let me show you, do it this way. So over here we have what we had earlier in 3 lines in 1 line. We have the lambda function over here, which simply is a function that has no formal definition. And over here you can see that we have this parameter and we are then squaring it. So in the first argument of the map function, over here we have, instead of adding an explicit function as we had before, added an anonymous lambda function. And we're applying this lambda function to all the numbers in the numbers list over here at the top, well, set more specifically. And if I go ahead and run this now, you'll see that the result is exactly the same. So we are still squaring each number in the numbers set. And that is how you use lambda functions with map. As the name already suggests, the filter function in Python allows you to filter elements from an iterable that satisfy a specific condition. So let's say you have a list of numbers 1, 2, 3, 4, 5, and 6, and you want to extract from this list the numbers that are even. So that would be 2, 4, and 6. And that is exactly one example filter where you could apply the filter function. So we're going to take a look at what filter does. Then we're going to have a look at how we use it with lists, tuples, and sets. Moving on, we're also going to have a look at how we can use it with lambda functions. And finally, we're going to look at a special case where the filter function is used with the parameter none to do something quite interesting. So let's get into it and look at what filter does. So what exactly does the filter function do and how do we use it? Let's say that we have a list of numbers, such as the one over here, and we would like to filter the numbers that are greater than the value of 6. And we want to create a new list with only the values 7 through to 10. One way that we could go about doing this is we could create an empty list, such as the results list over here. And subsequently, we could create a for loop, which is going to loop through the numbers list one by one. So we're taking the number in numbers, and we're going to check for each individual number if num is greater than 6. And if this statement is true, then we're going to append the number to the results list. And subsequently, we can go ahead and print the result out. So it should be no surprise that if I go ahead and execute this, we're going to get the desired result because we get the numbers 7 through to 10 in the console output. But let's see how we could do exactly the same thing in a bit of a simpler way by using the filter function. So if we were to use filter, we would first need to define a function to input as an argument. So we're going to define the function check greater than 6. And this function is going to check if a number is greater than 6 and subsequently return true if the number is greater than 6. But if it isn't, it is going to return false. All right, so how do we do that with the filter function? Over here, you can see I have a filter function. And what it does is it does exactly the same thing as the loop does over here. So we're going to get exactly the same result. But let's have a look at the syntax. So over here, we first have a function. And as a second argument, we have the numbers list. And so using these two arguments, we're then putting it into the filter function. And this over here is going to return a filter object. I'm going to write it as obj. And since it's going to return a filter object, that is not going to be legible for us. And that is exactly why we have also added the list over here at the front. So we're printing out a list of the filter object. And so let's go ahead and execute all of this, and you'll see that the result is going to be exactly the same as the one we had when we executed the loop. So let me go ahead and execute this, and you can see the result stays exactly the same. But let me just briefly show you that if I remove this list over here and remove the bracket at the back and execute all of this again, you can see that I'm getting a filter object. So that is exactly why I added the list to this print statement. Now, it doesn't necessarily need to be a list. It could also be a set, for example. So if I go ahead and execute this now, then pay attention to the brackets over here. I'm getting a set because these are curly brackets, but it could also, for example, be a tuple. Tuple. How do we write tuple? Tuple. There we go. And if I go ahead and now run this again, you can see that we have a regular tuple. Next up, I want to show you that we can use the filter function with different data types. Specifically, we can use it with things like lists, tuples, or even sets. So at the very top, I've created three distinct containers of data. The first one is a list, the second one is a tuple, and the third one is a set. And this time around, we're not going to look for values that are greater than 6. Instead, we are going to check if a number is even. So we have this function defined over here called checkEven, which is going to check if the remainder after the division of 2, which is exactly what this modulo operator does over here, is equal to 0. So this line over here is simply checking if there is any remainder after dividing by 2, and if there isn't, then we have an even number. But if there is, then we do not have an even number. So we are going to return false if it's not the case. And these results that we get from the filter functions, so you can see over here, I've created 3 filter functions, 1, 2, and 3. And these individual results are going to be saved in the result list, the result tuple, and the result set. And you can see each and every time I have added the function as the first argument, the checkEven function, and then as the second argument, I have added the container with the numbers, which is the list, the tuple, and at the bottom, the set. And finally, I am going to simply print out these individual filter objects. So as I showed you earlier, this is going to return a filter object, obj. And afterwards, if we then return it back into a legible form of data, we can turn it back into a set, tuple, or a list. So I've misspelled it down here. Let's make this into a list. And that is exactly going to give us the correct result. So let me go ahead and underline this. So this over here is going to be legible for us, and it's going to return only the even numbers. So in this case, it's going to be 2, 4, and 6 is the result that we would expect. So let's go ahead and execute this. Let's start off by only executing the first 3 print statements over here. And you can see in the console output, after I run this, that we get the filter objects. I'm not sure you can see. Now you can see. You have the 3 filter objects. But of course, we don't want to see the objects. They're not interesting for us. We actually want to see the results. So let's go ahead and execute this again. And now you can see we get the desired results because we have a set, a tuple, and a list with only the even numbers showing. So that is exactly how we can use filters with lists, tuples, and sets. Next up, let's have a look at how we can use filters with lambda functions. You'll remember at the beginning when we were creating a list with the values greater than 6, we used a for loop at the very beginning. The next thing we did is we created this function and then put it into the filter built-in function and added the number as an argument, and that also gave us the desired results, specifically a list with the numbers 7, 8, 9, and 10. But there is even a step further that we can take to make this even simpler, and that is by using lambda functions, and they are compatible with the built-in filter function as well. So let me show you how we can actually simplify this code that I have highlighted even further. So using lambda function, we could simply print the list of the filter object, and as an argument we can now pass in a lambda function, which is going to take x as an argument, and it's going to check if x is greater than 6. And if that's the case, then we're going to return it into our result. And of course, the second argument needs to be the numbers list. So then, if I go ahead and execute this over here, you can see I get the same result as I did earlier with all of this that I heard earlier. So if I execute the highlighted part, you can see I get the numbers 7, 8, 9, and 10. And if I execute this single line of code using a lambda statement, you can see I get exactly the same result. So that is exactly how you would use a lambda function with a filter. And let me give you a second example. You can also remember that we had another function called checkEven, which is going to check for even numbers. And if I go ahead and execute this, you can see that we had a numbers array. Let me perhaps copy it down here so we can see it. So there we go. So executing this, you can see I get the even numbers from the numbers array. And using a lambda function, so we're going to write lambda function again. One way we could do it is simply print out the list of the filter object, and that is going to take a lambda function. So we're going to write lambda, and it's going to take x as an argument, and then we're going to check if the modulo of 2 is going to be equal to 0. And then, in addition to that, we also need to add the numbers list as an argument. And if I go ahead and execute this, you can see the result is exactly the same. So bear in mind that you can also use these very handy lambda functions with the built-in filter function, which saves you from writing out an explicit function each and every time. The final thing that I want to cover is using the filter function with the parameter none. So over here you can see that I have a list, and the list is actually called a list, and in this list I have some arbitrary values. So there are values like false, true, 0 as a string, 0 as a number, none, and so on and so forth. And what I'm doing here is that in the filter function, I have put in none as a parameter where I would usually put a function. And in addition, I have also got the actual list as a parameter. So what will this actually filter out? Let's go ahead and have a look what this does. I'm going to execute the code that you see on the screen. So select it and execute it. And you can see that the results have filtered out a couple of the values from the initial list. So let's see what stayed in and let's see what was filtered out. So the 1 stayed in, the A stayed in, the 0 was filtered out, the false was filtered out, the true remained in, the 0 as a string remained in, the none was filtered out, the 12 was left in, and the hello was left in. So we can see that all this does is it filters the truthy. Truthy is sort of a nice word. It leaves the truthy values in the list. And what do I mean by truthy? Truthy are simply the values that would return true if I turned them into a Boolean. So let's see what that means if I go ahead and print out the bool of, for example, the value, let's see, 1, then you'll see that it returns true. And since it returns true, we are going to leave it in the list, and it is also going to be part of the new list once running through the filter. So the true will appear for all the individual values where I have left a tick underneath. So let's check this, for example, for a couple of other values. So the 12 over here was also a value that remained in the list, as you can see down here from the list which was output. And it is a truthy value because it returns true if we turn it into a Boolean value. You can see the 12 returns true, and in fact any number such as 15, 16, or any arbitrary number actually returns true with the exception of the 0. So the 0 does not return true, it returns false. And let's see what happens with a negative number. If I take -1, it also returns true. So 0 is the only number where the Boolean value of 0 is going to be returning false. And that the logic behind that applies to all the values over here. So let me give you one final example. If I, for example, take the Boolean value of the keyword none, then we are going to have false as an output. And since it is false, I have put a cross underneath here. It is not a truthy value, and it is also not output in the list. So that is exactly how the filter function works if you use none as a parameter. In Python, the reduce function allows us to take an iterable, such as a list, and condense it down to a single value. Let's have a look at what reduce does and how it works. Then we'll look at the syntax and the optional argument we can add to it. And finally, we'll have a look at how reduce works with lambda functions. So let's say we have a list over here, and we would like to find the sum of this list. One way we could go about doing this is to create a variable called total, set it to 0, then create a for loop and add each of the individual numbers in the numbers list to the total. And finally, print out the total. So if I execute this, you can see the value down here is 15 in the console output, and that is exactly the sum of the numbers in the list. So that's great, but there is another faster way to do this, which uses the reduce function. So let me scroll down a little bit. Over here in this code snippet, you can see that I imported reduce from the functional tools module, and I have the same list of numbers as I had in the example above. Then I went on and defined a function called sum, where I'm taking the sum of two values. So over here, I have x and y as two inputs, and I'm returning the sum of both of them. And at the very end, I'm printing what the reduce gives me if I put in the sum function as an argument and the numbers list as an argument. So you can see here, usually when we use reduce, we have a function in first place in the first argument and a list, set, or tuple, or any sort of iterable as the second parameter. So if I go ahead and run this now, you will be able to see that the result is also going to be 15. You can see in the console output, I reran it. It's giving us the result 15 because it is taking the sum of this list. To perhaps see what exactly is happening over here, it helps to print out the values of x and y that are being input into the sum function. So let me rerun this again, and we'll go through this step by step. So over here, you can see that once I've run this again, it's giving me this output. Now, what is happening over here? When I use the reduce function using the sum function and the numbers list, I start by adding the values 1 and 2 together. So these are also the first 2 in the numbers list. Once I've added them together, I get the result 3, and I add the next 3 to the result. And you can see that is exactly what's happening at the bottom. So I'm adding 3 and 3. Once I add the first 3 numbers together, I have 6, and I'm adding the fourth one to it. So you can see it's 6 plus 4. 6 plus 4 is 10, so that's the sum of all these numbers. And in the final step, I'm just adding the 5, so I'm getting 15. And the final print statement over here is returning the value 15. So that is exactly how the reduce function is working through the numbers to retrieve the sum. The next thing I want to show you is the syntax and the optional argument of the reduce function. So we have over here a tuple this time. Notice the rounded brackets. This is not a list, it's a tuple. And I have the same function I had earlier, which is simply the sum of x and y. And it's returning the addition of both. And over here, I am simply printing out the result of this reduce. So if I go ahead and run this, you can see I get the result 10 because 4 plus 3 plus 2 plus 1 is 10. All right, so now I want to show you that usually we do put a function in the first place, a iterable in the second place, but there is something else we can add to this function as an argument, which is an initial value. So notice what happens when I add 10 over here. Then the total that I get at the end is going to be 20, because it simply adds the initial value to the sum of the values from the list. So let me execute this again. You can see now it's 20 in the bottom. So the initial value, which is the third and last argument that you can add to this reduce function, simply tells us what value to start at. Okay, the final thing I want to cover is using the reduce function with lambda functions. So over here I have a numbers list, 2, 4, 6, 8, and 12. And as I mentioned earlier, the first argument in the reduce function is a function itself, but that function doesn't necessarily need to be defined explicitly. It can also be an anonymous function, such as a lambda function. So over here, you can see that if I choose to simply retrieve the sum of all the values, I can create a lambda function with 2 inputs that simply sums up the values. So if I go ahead and execute this, you can see I get 32, which is the sum of all the numbers in this list. Similarly, if I choose to find the maximum value in a list, we want to retrieve the maximum over here, I can execute this second statement over here, which simply checks if a value x is greater than y, then it is leaving the x. Otherwise, it's putting the y. So if I go ahead and run this, you can see it outputs the total value, 12, the maximum value, which is 12. Similarly, if we only want to retrieve the minimum value, we can turn around this greater than sign, make it a smaller than sign, and if I go ahead and execute this, I get the number 2, which is the minimum value. So what I want to show you here is that we can also use these lambda functions instead of explicitly defined functions. All right, so that's it for the reduce function in Python. When you think of the keyword else in Python, you usually associate that with if-else statements. However, there is another use of the else keyword, which is slightly less common and less well known. And that's the one we're going to go into right now, which is the for-else loops. So let's go ahead and compare how else is used in if statements and in for loops. So starting off with the use with if statements, most of you should be aware of how to use if-else statements. Over here we have an if-else statement, and basically what we're doing over here is we're checking if the apple is in the fruits list, and clearly in this list you can see that there are no apples. So that is why this top statement is going to return false, and we're going to move down to the else statement, and then whatever is in the else code block is going to be executed. And in this case it's simply a print of the sentence apple is not in the list. So if I go ahead and execute this, you will see that that is exactly what happens in the console output. We get the sentence which is over here printed in the console output because the apple is not in the list. So that is in essence how else statements work with an if. Basically, if whatever is written in the if statement does not apply, so whatever is written here returns false, then we move to the else statement, and that is executed. So let's now have a look how we can use the else keyword with for loops. So over here you can see that I have a list of numbers, and at the moment the 6 is missing, but let me put that in. So now it's correct. And right over here you can see that I have this for loop, and beneath that I have an else statement. So at the beginning, let's take a look at the for loop first. So over here I'm going to go through the numbers in the numbers list. I'm going to be printing the numbers, and if I get to the number 6, I'm going to break out of this top loop. And that is exactly what's going to happen because we do have a 6 over here. So that is why we're going to be breaking out of the for loop. So let me show you that. If we go ahead and execute this, you can see that the numbers 0 through 6 are printed. But since we're breaking out of the for loop, the remainder of the numbers are not printed anymore. So if I go ahead and remove the 6 and execute this again, so I'm only executing the highlighted code for the moment being and leaving out the else statement. But now you can see as soon as I remove the 6, it's going to go ahead and print out all the numbers because we're not breaking out of this loop anymore, since this if statement is not applying anymore as there is no 6 in the numbers list. And now let's see what happens if we go ahead and execute all of the code, including the else statement. So I'm now executing the code that is highlighted, including the else statement, and you can see something interesting happen, which is that at the very end of the loop, so once the numbers 1 to 10, excluding 6 because it's not in there anymore, so 1 to 10, excluding 6 is printed, we are getting the else statement being executed, which writes the sentence executed without a break. Now let's see what happens when we add the 6 back into the list. So now the difference is going to be that we are going to be breaking out of the loop again. We're going to be breaking out of the loop because the 6 is back in our list. So let me go ahead and now execute all of this again. And what you will see now is that we get the numbers 0 through to 6 printed, but the else statement does not get executed anymore. So that is exactly how the else statement works with a for loop. Whenever the for loop executes without breaking out of it, we have the else statement being executed. If, however, there is a break out of the for loop, the else statement is not executed. So that's how you use else with for loops, and that is also how they compare to their use with if statements. Let's have a look at zip and unzip in Python. Zip allows us to combine separate lists into one single list, and unzip does the exact opposite by allowing us to split a list into multiple lists. So let's have a look at how we can use zip to combine separate lists together. Over here you can see that I have a list of first names and a list of last names. And I want to put together these two names, and these two names. Specifically, for the first one, we would like to have the first name Albert and the last name Amt, and we want to proceed similarly with the last two entries. One way that we could do this is using the zip function. So over here you can see I've created a new variable called first and last name, which is a list, and it zips together the first name and the last name. So I've simply input the first name as the first parameter and the last name as the last parameter. And afterwards, to see the result, I'm printing out the result, and I'm also going to print out the type of this new variable to see that it is in fact a list. So this is going to be a list. Now I'm going to execute this, and you can see down here the result of the two print statements. The very first one is from the zipped up lists. So you can see that since we have square brackets at the very end, there's a square bracket here and a square bracket there. And since these are square brackets, we are in fact dealing with a list. But within this list, you can see that we also have 3 pairs of rounded brackets. So the zip function has put together the first and last names into tuples. So it's taken the first name Albert, for example, the last name Amt, and put it into a tuple, as you can see down here. And what that means is that we can access these elements in even more granular ways. So that means if we were to add an index at the very end over here, say 0, we could access the very first tuple. And we can access the first element of the first tuple by adding another index. So by using the 2 zeros, we would then be accessing the very first element of the very first tuple. Now, of course, we don't necessarily need to take 0, 0, but that's just an easy example. We could also take anything that is within the range of the lists. So if we would like to get belly out, then we could take the index 1 for the first tuple and the index 0 for the first element of the second tuple. So let's go ahead and try that actually. I'm going to zoom down a little bit further. And over here you can see that I have a few more examples. So using one index first, we can go ahead and execute this, and you'll see that I get the very first tuple over here being output. And you can also see that it is a tuple because I'm also printing the type of this element, and you can see it is of type tuple. And finally, using the 2 zeros at the very end to access the very first tuple and the first element within the tuple, you can see that I have Albert being output, and of course Albert is a string in itself. All right, so moving on, let's have a look at how we can use the zip function with loops. Over here you can see I have the first and last name lists as I did earlier, but just let me make sure that the pen has the right size. Okay, so over here you can see I have the first and last names, and these lists are the ones we used earlier. And let's say I want to create a string output in the console which says first name and then outputs the first name of the first person, and then last name and outputs the last name of the first person, and I want to do that for all 3 people in the list. So one slightly inconvenient way is the top one, because over here we have to work with indices right? So I have this index over here. I know that both of these lists have 3 elements, so I'm going through the range of 0 to 3, and remember the last element over here is not included, so we're going to be going through the values 0, 1, and 2, and that corresponds to the first and last name indices, which are going to be 0, 1, and 2. And so then I have the indices here which are going to make sure that we're having the right combination of first and last name. So if I were to execute this very first for loop, you'll be able to see that the desired output is achieved. We have first name Albert, last name Amt, and we have that happening for all 3 names. A slightly more convenient way using zip is to use it in the for loop as I have done over here. So you can see I have the first name, the last name, and then I'm zipping together the first name and last name, and I'm simply then printing out the same sentence as above, but now I'm using the first name and the last name as parameters over here. And you can see that the result is going to be exactly the same as it is above. So you can see exactly the same result. So you can say that the zip function does make for loops a little bit cleaner. The next thing I want to show you is what happens when a list is longer than another list when zipping together. So over here you can see that I have 4 elements at the top. So this Debbie name over here is a new one. So this has a length of 4, but the last name list has a length of 3. So let's try and zip this together and see what happens. And you can see, wait, let me clear that and let me run it again. So you can see that over here, even though I have added a new name to the list over here, even though this new name has appeared, the result has stayed the same as before. If you look earlier in the video, when we zipped together the list, this was what we got: Albert Amt, Belly Bob, and Cindy Cam. And Debbie is simply left out because there is nothing to zip it to in the second list, and that's why we forget about it. So just remember, with unequal lists, the unequal elements are simply left out. The next thing I want to show you is that we can also use multiple lists. So we've been using 2 all along, but we can go ahead and use more than that. So just to show you that it also works with 3, let me briefly execute this over here. You can see that we have the tuples, but now they have 3 elements. So we've simply added 1 more value. That's no problem. So bear in mind that you can use more than 2 lists when zipping together. And finally, I want to show you that we can also use unzip to split. Now, when using unzip, you actually still have to use the zip function, but you use it in combination with an asterisk. So let me show you how that works. Over here, you can see that I have a full name list. So over here, we have the individual tuples denoted by the rounded brackets. And within these tuples, we have a first name, last name, and an age. And now let's say we want to split this up. So we want these first names in a list, we want the last names in a second list, and we want the ages in a third list. So this is going to be 1, 2, 3 lists. The way to do that would be to write first name, comma, last name, comma, age. So these are going to be the names of the individual lists. And then what we do is we use zip over here, and we have to input as an argument the list we want to split, which is the full name list, which corresponds to the full name list over here. So I've simply put that in there. But in addition, you have to make sure to use this small star over here, because that is going to unzip the list into these individual lists that we have over here. And once that's done, we can go ahead and simply execute this. And if we do, you will see that we have individual lists. So in the bottom, you can see the first names, and you have the first names only. Then you have the last names, which are the last names, and the ages, which contain only the ages. So that is exactly how you unzip to split a long list like this one into separate individual lists. Let us talk about Python collections. When we talk about Python collections, we are referring to containers of data. In Python, the built-in collections include lists, tuples, sets, and dictionaries. So we're going to take a look at how we can create empty collections. Then we're going to create non-empty collections with data inside. After that, we're going to be accessing the data. We're going to make changes to the data. We're going to add and remove data. And finally, we're going to look at if we can sort the data. So to start off, let's go ahead and create some empty collections. And we're going to start off by creating some empty lists. If we want to create an empty list, all we need to do is we need to write a pair of empty square brackets. An empty tuple needs an empty pair of rounded brackets. For an empty set, you need to write something slightly strange. So over here, you need to write these curly braces. And inside the curly braces, you need to write a star and a pair of rounded brackets. And for a dictionary, all you need to do is write a pair of these curly braces. Then for each of the individual collections, you can also use the keyword method to create an empty list, set, tuple, or dictionary by simply using the corresponding keywords. So over here for a list, we simply write list with empty brackets. For tuple, we write tuple with empty brackets. For a set, we write set with empty brackets. And for a dictionary, we write dictionary with empty brackets. If I then go ahead and execute these individual print statements, you will see that the lists are in fact of the correct data type. So executing the first two print statements, you can see that we have two lists. Then below that, we have two tuples. Below that, we have two sets. And at the very end, we have two dictionaries. So that is exactly how we can create these empty collections. Moving forward, let's go ahead and learn how we can actually add data to these individual collections. To add data to a list, all you need to do is write the data within the square brackets, and you will have a list with data inside. Over here, I have just added some integers, a boolean, and some string values. For a tuple, you can do exactly the same thing, but you'll be using these rounded brackets. For a set, you can do exactly the same thing, but you'll be using these curly brackets. And for a dictionary, you need to watch out because for dictionaries, you always need to add items that consist of a key and a value. So over here, we have three keys, the 1, 2, and 3, and we have three values, which is the apple, the cherry, and the strawberry. And you want to bear in mind that when you use the keywords to create a dictionary, so when you write dictionary, you cannot add a list as an argument. So this won't work over here. And neither will the example below where we're using a tuple and inserting it into the dictionary keyword. So these two examples will return an error. But at the very end, I have these curly braces, and I'm adding them within the dictionary keyword, so that is going to work. So all this should show you is that you can create filled lists, tuples, sets, and dictionaries in several different ways. Now I do want to point out one more thing, and that is that whenever you create sets, you're going to be deleting duplicate values. So over here you can see that I have a set, and I have put that set within this list keyword. But when I go ahead and print this list, what we'll see is that the 2 is deleted, one of the A's is deleted, and in addition to that, what many people don't know is that the true will also be deleted. And the reason why this true is going to be deleted is because within the set, it is detected to be the same as the 1. So let me go ahead and show you that by briefly printing the result of list 6. You will be able to see that we get in the console output the values 1, 2, C, and A, and that is exactly what I just predicted would happen. So the true is deleted, one of the 2's is deleted, and the A is deleted. And that is also going to happen if you use the tuple and insert into the keyword tuple a set. So you'll see exactly the same phenomenon pop up over here. So if I go ahead and execute this, you will see that one of the 2's has been deleted, the true has been deleted, and the A has been deleted. So just to bear that in mind, you should know that whenever you use these sets, the duplicate values always get removed. Now, how do we go about accessing data within these individual collections? If you want to access an individual element of a list, you can simply write the name of the list, and then within square brackets, you write the index of the element you want to access. And remember, with lists, the index starts with 0, then goes 1, 2, 3, 4, 5, and 6. And so over here, with this example, we're going to be printing the third element, which is going to be the true value over here. In addition to that, you can also access items from the back. That means over here you have a negative symbol in front of the number. And so if you want to access from back to front, this is going to have the negative index 1, this is going to have the negative index 2, this is going to have the negative index 3, and so on and so forth. So let me just show to you that that in fact does work. Over here in the console output, you can see the two results that we expect, which is first the true, which is the result of taking the third element over here. And in addition to that, you can also see the string C being printed out, which is the result of taking the negative index over here. In addition to that, you can also use the slice method, which gives you the elements between two indices. So if you want to take elements between two indices, you have to use a starting index, then the colon, and then an ending index. So if I go ahead and execute this slice over here, you get the elements 1 and 2, which corresponds to the first elements over here. So these two are the result of this slice. With tuples, the access to data is in fact very similar to lists. So if you want to access an index by item, you can do that in pretty much the same way you would with a list. You can access items from back to front by using negative indexes, and then you can also use the slice method that I demonstrated above. With sets, it's a bit more complicated because you cannot access individual items. Sets are by definition unordered. So if you try and access a set value using an index, as I have done here, you're going to get an error. You can try that, but this will not work. For dictionaries, the access to data is also quite interesting because you always have to deal with these key value pairs. So if you want to access the value of a specific element at a specific key, you write the name of the dictionary and then the key value in square brackets. So this is going to give you the element cherry because it is the value at the key number 2. If you want to access all the keys, then you simply write the name of the dictionary and then dot keys. If you want to access all the values, you can write the name of the dictionary and then dot values. And finally, if you want to access all the items, which consist of a key and a value, then you simply write the name of the dictionary and items. And let me just briefly execute that so we can see that it also works. And let me make it a bit bigger. So yeah, this has worked just the way that we expected it to. So over here we have accessed the dictionary item at the key 2, which is cherry, and that is this output. Then we have accessed all the keys, which was the second printed output. Then we have also accessed all the individual items, and then finally the key value pairs, which is down here, always given by a key and a value. Let us now move on to changing the entries in these individual collections. If you want to change a value within a list, you have to first access it by writing the name of the list and the index of the item you want to change. So in this case, we chose the item number 1, and since the first element has the index 0, the second element has the index 1. So we're changing this 2 into the value 15 in this case. So by printing out this list over here, you'll see that the second item has changed to 15. So if we pay attention to the 2 over here and the 15 over here, that is exactly what has changed. How about changing the value of a tuple? Now, tuples are what we call immutable. Immutable simply means that after you've defined a certain tuple, you cannot change it anymore. So trying to do the same thing as we did above with lists will fail, so that will not work anymore. How about changing the value in a set? Now, changing the value in a set won't work either because sets are what we call unordered. The order of the elements in the set is not given specifically. So we cannot access the individual items by using an index, and that's why we cannot change individual items. So this is not going to work either. Then finally, with dictionaries, we are able to change individual items. Let's try and change a specific entry. Let's say we want to change the apple over here to a banana. Then we need to write the name of the dictionary, the key of the item we want to change. So over here, since we have the apple at key 1, which we want to change, we need to write the key into these square brackets and then assign it the new value, which is banana. And subsequently, if we execute this, you can see that now the banana is given in the list, in the dictionary, instead of the apple. And now let's say that instead of changing a value, we want to change the key of an item, because remember, these dictionaries also have keys. So let's say we would like to change the key of the cherry to the number 4. So instead of the number 2, it should be 4. The way to do that would be write the name of the dictionary, then the key of the item you want to change, and then write dictionary and then pop and then the index 2. So if we go ahead and execute this, you'll see that the cherry over here has been changed because the key of the cherry is now 4 and not 2 anymore. So this is how you change the key. Next up, let's talk about adding and removing values from these individual collections. Starting off again with lists. Let's say we want to add a value. The way to do that is by using the keyword append. So we're appending the string D to this list. If we go ahead and print it after we use this append statement, you'll see that down in the console output, we have this D which has been added to the end of the list. Similarly, if we want to remove an item from the list, we can go ahead and use the keyword pop. And so now we are popping the element at the index 0, which would be the 1 over here. So you'll see that if we print the list afterwards, the 1 will be gone. Let's see if that does apply. And yes, that is exactly what happens. Down here, you can see that I've popped it once and accidentally executed twice. So after the first execution, you can see that the very first element was popped because the 1 is missing over here. And then since I executed it again, it popped one of the 2's. So every time you execute this statement over here, you will see that the very first index element will be gone. So I can actually go ahead and pop through the entire list by executing the statement over and over again. Let me go ahead and do that a couple more times. And you can see all the values are gradually gone. See, now the list is empty because I've popped away all the values. With tuples, we again have the problem that they are immutable. That means we cannot change them after they are defined. So there's no adding or removing entries in this case. Moving on to sets, we can actually add values to a set by using the keyword add. So over here, we have a set of numbers, and we are adding the value 12 to this set. So if we go ahead and run this, you can see that now the set has the value 12. And in addition, remember that the set automatically always removes the duplicate values, so you won't be seeing two A's, you won't be seeing two 2's, and you also won't be seeing this true value, because as I stated earlier in this part, it is considered equivalent to the 1. But you will see the 12 now that it has been added. And you can also go ahead and remove individual values from the set, but you can't specify what values you remove, because it is always going to remove a random value, because you cannot pass in any index, because these sets are unordered. So let's go ahead and remove a couple of these values. So if I go ahead and execute this a couple of times, you can see that now the set has become quite small after a couple random values have been popped away. And last but not least, let's talk about how we can do this with dictionaries. So how can we add and remove items from dictionaries? Over here you can see I have dictionary number 9 with a total of 3 items, and I want to add the 4th item, and I do this with the word update. So if we go ahead and update the dictionary, you can see that now the dictionary also has this banana, which I chose to insert. And if we want to remove an element, we can simply write the index of the element we want to remove and then pop it from the dictionary. So let me go ahead and execute this. And now you'll see that the apple has been removed from the dictionary down here because I have popped it. So that is how you can add and remove data from these individual collections. Last but not least, let's talk about sorting the data in collections. When we talk about sorting data, there are really 2 possibilities, either by using the method sort or by using the method sorted. Now there is actually a difference between these 2, which is that if we use sort, we are making changes to the original collection, whereas if we use sorted, we are simply returning the sorted collection. There is a distinct difference, and so if we try and look at what that means for sorting the individual collections, if, for example, we have a list over here and we want to return it in ascending order, we can go ahead and sort it and print it out. So let's go ahead and do that. And you can see that it has made this list such that each of the items is arranged in ascending order. But similarly, we could have also used the sorted method, because over here it returns the value. So if we go ahead and execute this, you can see we get exactly the same result. Now, as I mentioned just a moment ago, and this is pretty difficult to wrap your head around, but bear with me, if I would have taken this sort and put it into the print statement directly, I would not get any result. So let me show you that. If I execute this, I get none. And that is because the sort does not have any return value, whereas the sorted value, which provides a copy of the original list and sorts it, does have a return value. So as I mentioned before, bear that in mind, that when you use sort, there is no return and it makes changes to the original collection. But here with sorted, no changes are made to the original collection, but a returned copy is made that is sorted. And another thing that you should bear in mind is that if I were to want to provide a list which is given in descending order, I can simply write reverse equals true. And if I go ahead and execute this, you'll see that now the reverse order is given of the list, which is really nice. So moving on to tuples, as I stated a moment ago, the sort method cannot be used because we're making changes to the original. And as we stated earlier, tuples are immutable. That means after they've been defined, they can't be changed anymore. So the closest we can get to sorting anything with a tuple is in fact by using the sorted method, which simply returns a copy which is sorted in ascending order. So if we go ahead and execute this, you can see that we get a list printed out. And I mean, bear that in mind, that it is in fact a list, a sorted list, and it is not a tuple anymore. And it is now given the numbers in ascending order, as you can see down here. Now moving on, let's talk about the set. And with sets, it's of course pretty difficult to sort them because they are by definition unsorted. So one thing that we can do is use the sorted method again, and it will return the numbers in sorted order. So if I go ahead and execute this, you can see the duplicates are deleted. So the number 2 is deleted, the number 1 is deleted, and then the rest of the numbers are put into ascending order, as you can see down here in the console output. Now finally, with dictionaries, can we sort dictionaries? Yes, we can. By using sorted again, over here we have got the dictionary number 10, and if we use sorted on this dictionary, it is going to return the dictionary with ascending key numbers. So now you can see after I've sorted the dictionary, the numbers 1, 2, and 3 appear down here in the console output, and that is because it has sorted the keys. Now, if I want to obtain all the items, I could equally write items behind that. Items, or wait, hold on, does that work? Oh no, I have to write it over here. So dot items, and it would do exactly the same thing, but now it would sort the items also by the key, but it would also output the value as well. So that is how sorting works with these individual collections. In Python, lambda functions are frequently called anonymous functions because they don't require any formal definition. So let's take a look at how we can declare and call lambda functions, how we can use lambda functions with multiple arguments, and what the key properties of these lambda functions are. Starting off with declaring and calling a lambda function. So at the top over here, I have declared and called a regular function. And as you would usually go about doing this, I have got the keyword define, and I've defined the function greet, and it's called greet regular because it's a regular greeting function. And all it does is it prints the hello world string. And if I want to call this function, all I need to do is I need to write the name of the function followed by the parentheses. And in this case, they're empty because there's no arguments that I need to input. So if I go ahead and execute this, you'll see that to no surprise, it says hello world in the console output. But how would we do that using a lambda function? So that is exactly what I have at the bottom over here. So to declare a lambda function, you could write the name greet lambda as the name, and then over here is where the interesting part starts. This is where we have the lambda function. And in this case, all it does is it prints hello world, and it does not take any arguments. So all it does is as soon as you call this lambda function, it will go ahead and print hello world. And you call the lambda function by simply writing greet lambda and then writing the empty brackets around here. So the function call looks very similar to the one of a regular function. But let me just demonstrate that this will in fact call the lambda function. If I go ahead and execute this, you can see that it still says hello world after executing this lambda statement over here. But let's see what happens if we add a couple of arguments to a lambda function. So what could a lambda function with arguments look like? Over here we have declared the lambda function x, and it has one argument, which is a, and all we're doing over here is we're adding the value of 10 to the value of a. So if we go ahead and call this lambda function and input an argument, then we can do it in two ways, either using a keyword, or, oh, this is horrible writing, but it's meant to say keyword. Maybe I'll abbreviate that with KW. And at the bottom over here, I'm simply using a positional argument. And both of these will call this lambda function and execute it. So if I go ahead and execute this, you'll see both of them give me the value of 15, because putting the 5 into the lambda function for a gives me the value of 15. So how does that work if we have more than one argument? I'm sorry. So at the top we saw one argument, but now we have two. So how does this work now? If we have two arguments, and in this case the lambda function simply adds the two values together, we need to input two values into the call. So over here we've done this with a keyword and with a positional argument, and both will also lead to the correct result. So let me go ahead and execute them. Both yield the value 24, because if you add 10 and 14, you get 24. And so on and so forth. So you can go ahead and add as many arguments as you want. Let's go ahead and do this one more time for the last lambda function over here, for lambda function z. So I have gone ahead and given this lambda function 3 arguments, and I'm simply adding them together. And over here in the function call, I am simply inputting the values as keywords. I wouldn't have to do that. I could also leave these away, but let me just go ahead and execute that, and you'll see that it outputs 6, because 3 plus 2 plus 1 is 6. Now let us have a look at some of the key properties of lambda functions. The first key property of a lambda function is that it can be invoked immediately. When you think of a regular function, you need to remember that you first need to define it formally. For example, over here we have defined the function multiply, and it takes 2 arguments and it returns the product of them. So it multiplies the 2 arguments together. And you can't invoke this immediately because you always need to call it first. So over here we have a call to the function multiply, and we're inputting the numbers 2 and 2, so we're multiplying 2 and 2 together. But with lambda functions, on the other hand, we have the definition, and right after the definition we're passing in the arguments. So in this one line of code, we have defined and invoked the function all at once. So to show you that this works, let me go ahead and first off execute the normal function. So over here you can see we're getting the product of 2 and 2, which is 4. And at the bottom, if I execute this lambda function, I'm getting the value 35 because it's multiplying 5 and 7. So bear in mind that with lambda functions, they can be invoked directly right after their definition, which is quite handy. The second key property of lambda functions is that they're frequently used with map, reduce, and filter. With map, reduce, and filter, the first argument is always a function. So over here we have map, filter, and reduce, and the very first argument is always a function. Now, defining this function explicitly is always a bit cumbersome, and that's why we use these anonymous functions very frequently with these 3 functions, map, filter, and reduce. So let me go through these individual examples. So over here with map, what I'm doing is that I'm taking the square and squaring every number in the numbers list. Then for the filter example, I am filtering only the even numbers. So we are going to retrieve a list with only even numbers. And for the reduce over here, what I'm doing is I am simply returning the sum of all the numbers in the numbers list. So let me go ahead and execute all of this. And as expected, the first list over here shows you the squared value of each of the numbers in the numbers list. Then we get all the even numbers, and finally we get the sum of all the numbers put together. So bear in mind that lambda functions are frequently used with map, reduce, and filter because they're convenient, as you don't need to always define the function. Now finally, the last key property of lambda functions is that they can actually also be nested. So over here you can see that I have a lambda function, and I have given it the name nested lambda. And then I have called the nested lambda function, and within the call I have gone ahead and given it two arguments, which is a number, and in addition to that I have defined another lambda function within this. So I have a lambda function effectively within another, and if we go ahead and execute this, you can see that it returns the value of 30 because it's taking the 10, multiplying it by 2, and then adding the 10 again. So that is how we get the value of 30 in this case. Let's take a look at how we can create classes and instantiate objects in Python. We are going to see that classes help us group attributes and methods together in a logical and reusable way. One way to think about classes and objects is that classes provide a blueprint for creating individual objects. The best way to explain all of this is by looking at an example. So let's take a look at the following one. Let's assume that we're creating an application to help a public university manage its students. So let's start simple and create the class student. At the moment, this class is not going to do anything, which is why we're going to write the keyword pass underneath. As I mentioned earlier, classes are blueprints for objects. So now that we have a blueprint, how about we create an object? To create our very first object, all we need to do is write a variable name such as student_1 and set it equal to student. And what we're going to do below that is quite simply print out the student_1. If I go ahead and execute this, you will see in the console output that it says that I've created a student object, and besides that, it will also give you the memory location of where this object is saved. You can, of course, create more than one student by instantiating a new object under a new variable name. So you could, for example, write student_2 equals student, and as before, I can also find the storage location in memory of the second student by printing out student_2. And if we execute this, you will now also see the storage location of student2. But let's leave the second student away for the moment, and let's create some attributes for the first student, such as a first name and a last name. One way to do this would be to write out student_1 dot first name, and then set it equal to the value of the first name, which could, for example, be Max. We can create the last name in similar fashion by writing student_1 dot last name is equal to Griffin. To see that we've correctly assigned these attributes to the student, all we need to do is go to our print statement and write student_1 dot first name, and then we're going to copy this print statement a second time and write student_1 dot last name. Once we execute these two print statements, you will see that we have retrieved the attributes that we have assigned just a moment ago. But this method of assigning attributes to an object is quite cumbersome. Another more simpler way is to use a constructor in the class. So let's get rid of the pass statement within the student class and define an init method. And you will see that whenever I create a method within the student class, the self parameter is going to be added by default. And for those of you who are now wondering what the self parameter is, it is quite simply an instance of the student class, so a specific student. Since a lot of people have problems understanding self, let's really try to grasp this concept. I'm going to add a print statement within the init function, and all it's going to do is it's going to print self. Below that, I still have the student1 from earlier, which is an instance of the class student. So now when I go ahead and execute the selected code, I'm going to be creating an instance of the class student, and since the init method runs whenever an instance of the class is made, it is going to run the print statement inside of it. And in the console output, you will see a result that is similar to the one that we had earlier in this video, where we saw that we created a student object and we also have a memory location. So as you can see here, when I print out self, all I get is the instance of the class student, which is a specific student, and in this case, it's the student number 1. So now if I want to go ahead and add the attributes first name and last name, I can simply write self.firstname equals Max and self.lastname equals Griffin in the init method of the student class. To see that these attributes have been assigned to the student 1, all I need to do is write a print statement, and within the print statement I'm going to write student_1.firstname, and within another print statement I'm going to write student_1.lastname. Now if I go ahead and execute all of this, you will see in the console output I get the first and last name that we assigned to the student. The problem that I have now is that whenever I create a student, the first name will always be Max and the last name will always be Griffin. So it would be helpful if we could pass the first name and the last name into the init method as a parameter. To do that, I'm going to add the parameters first and last to the init method, and I'm going to assign the first to the first name and the last to the last name. And in the line below that, where I'm creating the instance of the student class, I now need to pass in 2 positional arguments, one for the first name and one for the last name. As the first name, let's just choose John, and as the last name, we'll choose Deer. To access these attributes, all I need to do is write 2 print statements. I'm going to use student_1 and then dot first name, and in the subsequent print statement I'm going to write student_1.lastname, and in the console output after I execute this, you will see that we get the name John Deere. Now that we know how to add attributes to an object using the init method, which is called whenever an instance of an object is made, I want to take a look at a new class method. Let's assume that at the university there are a lot of students, and it can occur that a student decides to pick a new major. So we want to add a function to the student class that allows the administrative staff to make this change in the system. First off, we're going to go back into the init method and we're going to create a new parameter called major. And we're going to write self.major is equal to major. So now when we create an individual student using the student class, we also need to pass in the major that he's currently pursuing. For the example below, let's just say that John Deere is studying computer science. Now let's create the function that allows us to make changes to this major. We're going to define the function changeMajor, and as an argument, it is going to take the instance of the object as well as the new major to which the student has switched to. All this function is going to do is it's going to make the change in the major, and in addition to that, it is also going to print out the first name of the student, the last name of the student, and the new major to which he has switched to. So let's now go ahead and call this function on the student John Deere and change his major from computer science to mechanical engineering. To do that, all we need to do is write student_1 dot and then the name of the function, which is changeMajor, and as an argument, we're passing in the new major, which is mechanical engineering. Once I execute the code that I have just highlighted over here, you will see that the major will be changed to mechanical engineering, and the print statement will be printed saying that John Deere has switched to mechanical engineering. And the amazing thing about classes is that we can create as many students as we want, and we can call the functions within the student class on each of the individual students that we create. So there is absolutely no problem with creating a student_2, setting it equal to a new instance of the class student by writing student, bracket open, and then let's call him Peter Oliver, and give him the major mechanical engineering. And as before, we can also proceed to access one of these attributes by, for example, printing out the student_2.major. And in the console output, you'll see that student2's major is mechanical engineering. And we can also choose to run the function change major on this new student because he is also an instance of the student class. So let's simply write out student underscore 2 dot change major, and let's change his major to biology. In the console output, you will now see that this student has changed his major to biology. So as you can see, we can create multiple students, and we can also run the functions within the student class on each of these individual students. When we talk about inheritance in Python, we usually talk about some child class receiving attributes and methods from some parent class. And the convenient thing about inheritance is that in the child class, we can override attributes and add even more methods without any effect on the parent class. As always, I think it's easiest to demonstrate all of this using a simple example. Let's assume for a moment that we're looking at a university with a diverse body of students, and some of these students are exchange students from other universities. So let's go ahead and create the class student. And this class is not going to do anything for the moment, so we're going to write pass underneath. In addition to this class, we're also going to create the class exchange student, which inherits from the class student. And equally, this class is not going to do anything for the moment, so we're also going to write pass underneath. Even though both of these classes don't do anything at the moment, we can already make instances of both of these classes. To create an instance of the student class, we can write student underscore 1 equals student. And similarly, if we want to create an instance of the child class exchange student, we can write exchange student 1 is equal to exchange student. If we now go ahead and print student 1 and subsequently print exchange student 1, we will see in the console output that we have a student object and an exchange student object that we've created. By doing this, we've already created an instance of the parent class student, as well as an instance of the child class exchange student. Let's move on and create some attributes for the student class. Let's say that our student has a first name, a last name, and perhaps a major. So we can create a constructor with an init method, which takes as parameters the first name, the last name, and the major. And subsequently, below that, we can write self.firstname is equal to the first name, self.lastname is equal to the last name, and self.major is equal to the student's major. So now, in the student object that we've created below the classes, we can pass in a first name such as Peter, a last name such as Parker, and a major such as history. And you won't be surprised that we can actually access these individual attributes as well. So if I, for example, print student1.firstname, you can see that in the console output, it will show me the first name of the student. And let me show you that this also works for the other attributes. So if I create this print statement for the last name, and also for the student's major, and run this again, you will see that these individual attributes are displayed in the console output. But now let's move to the child class exchange student, because it gets more interesting here. Since the child class exchange student inherits from the student class, I can also go ahead and add the attributes first name, last name, and major to the exchange student object. So let me give the exchange student the first name Evan, the last name Hill, and the major biology. I can now also access these individual attributes by printing out exchange student 1.firstname, exchange student 1.lastname, and exchange student 1.major. But at the moment, we're not really making any use of the child class exchange student. One way that we could make use of it is by adding an attribute that is not in the parent class. And one attribute that the exchange student should have, but a regular student shouldn't, is a home university, because after all, the exchange student comes from a different university somewhere abroad. So what we need to do in this case is we need to create an init method in the exchange student class, and this init method takes as parameters the first name, the last name, the major, and the home university. But the first name, the last name, and the major are already within the parent class. So what we can do here is simply execute the init method of the student class by writing student.init and passing in the first name, the last name, and the major. But for the additional parameter called home university, we need to write self.homeuniversity is equal to home university. So one thing that we can now do for the exchange student, which we cannot do for the normal student, is we can add a home university. So let me go ahead and add it to this instance of the exchange student over here by writing Oxford University for the exchange student 1. And accessing this attribute works similar to as it did before. We can simply go ahead and write a print statement and write exchange student 1 dot home university, and you'll see that it displays Oxford University for the exchange student we've just created. So now that we've played around with the inheritance of attributes, let's take a look at how this works with methods. Let's, for example, give the student class a function that allows us to print the first name and the last name. So we're going to define the print name function, which takes as an argument only the instance itself, and it prints out the first name and the last name of the student. So if I now have an instance of the student object and go ahead and run the print name method on this student, you will see that it prints out the first name and the last name in the console. This will also work for the exchange student without any problems. So for example, if I write exchange student 1.print name, you will also see that the print name function is available for the child class because the first name and last name of the exchange student that I've created are printed. One last thing that I want to mention is that instead of using the parent class name over here, we can use the method super. The super function returns a temporary object of the parent class and allows us to access its methods. So in this case, we can also remove the instance of the object, self, from the brackets over here. Now you'll see that when I run this in the console output, the result remains exactly the same. This function becomes particularly useful if you have very large files where you might change the name of a parent class. Because in that case, if you use super, you don't have to change all the references to the parent class. Let's talk about decorators in Python. Decorators allow us to extend the functionality of the function being decorated. And the word decorator is actually quite fitting because similar to the way you can decorate a Christmas tree with more Christmas lights, you can also decorate a function with more functionality. The first thing that you expect to see when we talk about decorators is some definition of a function, and above that we have an @ and some decorator name. And we will see this notation in just a moment, but before we do, consider the following functions. We're going to define a function called regular, and it takes no arguments, and all it does is print out the sentence regular function executed. In addition, I'm going to define the function decorator, and it is going to take a function as an argument, and since we will be passing in the regular function, let me just write regular as the argument name. And this function we've just defined is going to return a call to a function called wrapper. And now, between the function definition and the return statement, we're going to define the function wrapper. And it is going to have a print statement that prints wrapper function executed, and it is going to return a call to the function being passed in as an argument. Now, if I create a call to the decorator function and pass in the regular function, you will see that it will say in the console output that the wrapper function is executed, and afterwards the regular function is executed. This happens because when we call the decorator function, we first return a call to the wrapper function, which executes the first print statement wrapper function executed, and afterwards we return a call to the regular function, which prints out regular function executed. Now, if we were to remove the brackets that come after the wrapper in the return statement, we would not be returning a call to the wrapper function anymore, but instead we would be returning the function itself. So when I execute this now, you can see that nothing is printed in the console. If I want the same result as before, I would need to create a new variable name, for example, regular_decorated, and save the function to this variable by setting it equal to decorator and then in parentheses regular. And now I can call the regular_decorated function, and you'll see the result will be the same as before. And now comes the point where we actually get to see the decorator notation that I mentioned earlier in this video. Because what I can do here is simply write @decorator above the definition for the regular function and simply call the regular function. So now you can see that I have exactly the same result that I had earlier when I saved the function to a variable and then executed it. So to make that excessively clear to everybody, it doesn't matter if I use the decorator and a simple call to the function, as I am doing right here, or if instead I get rid of the decorator and save the function to a variable and then execute the function. The results are going to be the same. And you can see this from the console output because it says wrapper function executed and then it says regular function executed, which is what we had earlier. The next thing I want to show you is that you can actually chain together decorators and use more than one. So for the decorator function that we already have, we're going to add an _1, and in the print statement, we're going to write wrapper function 1 executed. Now let's go ahead and duplicate this decorator function, but now we're going to add an _2, and in the print statement, we're also going to write 2. Finally, above the regular function, we're going to write @decorator_1 and @decorator_2. When I run this now, you will see in the console output that it says wrapper function 2 executed, afterwards wrapper function 1 was executed, and at the very end we had the regular function executed. Now some of you might wonder what the equivalent of this would be if we were to not use any decorators. So let's go ahead and get rid of the decorators and create a new variable name called regular_decorated, which we also used earlier. And we're going to set that equal to decorator2, then within brackets decorator1, and then within brackets regular. In other words, we're passing the regular function into the decorator1 function, and we're then taking all of that and passing that into the decorator2 function. And since all of this returns a function, which I'm saving into the regular_decorated variable, I can then go ahead and execute it by writing regular_decorated and then parentheses. If I now go ahead and execute this, you can see that the result stays exactly the same as it was before. The last thing that I want to go into is how we can use decorators if we're dealing with functions that take arguments. So let me paste back in what we had earlier when we had the decorator function and the regular function. But now in the regular function, we're going to add an argument arg, and we're going to print out regular function executed with arg, and then we're also going to add the argument as a string that we're passing in. So let's see what happens when I execute this decorated regular function by creating a call to the function and passing in the argument test, for example. You can see that I get an error in the console and it says that the wrapper takes 0 positional arguments but 1 was given. So it doesn't like that I've added an argument to the regular function. So let's see how we can adjust the decorator function to make it account for a variable number of arguments that we pass in. To account for any number of arguments that I'm passing into this function, I can use *args and *quargs. And I'm going to add that to the wrapper function and in the return statement to the function down here. Now I do want to mention that you don't necessarily need to use the names args and quargs, but what you do need to use is the 1* and the 2* over here. But now when I execute this again, you will see in the console output it will say wrapper function executed and then regular function executed with the argument test that we passed into the function call.